Hi, this is Ajay from Institute of Aeronautical Engineering, pursuing BTech third year in Data Science stream. In this video, I will be discussing regarding the Turing machine. Before going to the calculation part of Turing machine, first we will have a little bit introduction regarding the Turing machine. So, Turing machine was actually invented in 1936 by Alan Turing. It is an accepting device which accepts the recursive enumerable language generated by type 0 grammar. So there are various features of Turing machine. So the first feature is that it has an external memory which remembers the arbitrary long sequence of input, and it has an unlimited memory capability, and the model has a facility by which the input at left or right on the tape can be read easily, and the machine can produce a certain output based on its input. Sometimes it may be required that same output has to be used to generate the output. So in this machine, the distinction between the input and output has been removed. So thus a common set of alphabets can be used for the Turing machine. So the Turing machine was invented in 1936 by Alan Turing, and it is a device which is used to accept the enumerable or recursive enumerable language, and it has features like it has an external memory, unlimited memory capability, and a facility by which the input at its left or right on the tape can be read easily. So that is about the introduction towards the Turing machine. Now the formal definition of Turing machine is nothing but a collection of seven tuples, in which it has a seven components, that is q, sigma, t, q naught, f, b, and delta. So q is nothing but the finite set of states, and sigma is nothing but the finite set of input symbols. What are the inputs we give into the machine? Next, t is the tape symbols. Q naught is the initial state, and f is the set of final states. B is a blank symbol used as a end mark for the input, and delta is a transition or mapping function, as we have solved in finite automata, epsilon finite automata, etc. And the mapping function shows that mapping from states of finite automata and input symbols on the tape to the next states, external symbols, and the direction for moving the tape head. So this is known as a triple or a program for Turing machine. And here we have mentioned an example. So if we give a symbol A to the state Q0, then it will go to the state Q1 where A is replaced by X, and R, in the sense the head pointer will be moving to the right. So that is about the transition state. So now we will solve an example using machine. So here it is an example. Construct a Turing machine for the language L, that is 0 power n, 1 power n, where n is greater than or equals to 1. So according to the solution, the main disadvantage of Turing machine is that we have a main advantage of Turing machine is that we have a tape head which can be moved forward or backward, and the input tape can be scanned. So the simple logic which we apply here is about where we apply is read out each zero, mark it by A, and then move ahead along with the input tape and find out one, convert it to B. Now repeat this process for all A's and B's. So the simple logic is that um, we should read out each zero, mark it by A, and then move the head along with the input tape. If the tape is R, then move to right. If the tape is L, then move to left. And similarly, find out ones and then convert them into B's. Now repeat this process for all A's and B's. So now we will see how Turing machine work for 0011 string. Okay. So the simulation for 0011 is represented as an array here. So here 0011, the last is delta. So now we will see how Turing machine works for 0011. Initially the state is Q0 and head is pointing to a 0 here. And then the move will be delta of Q0 of 0. So initially it is in q naught state, and if we give 0, then that will be transformed to delta of q1, where 0 is replaced by a and the pointer is moved towards the right. So here we observe the 0 is replaced by a in the first element, for the first element 0, and the header moved towards right. And in the next step the move will be, now the pointer is at q1 state. So if we give 0 as input to this q1 state, then uh, it will be transformed to same q1, and there is no replacement, it will be 0 and the pointer will be moved towards the right, which means it will not change any symbol, remain the same state and move towards the right. Next, if we give q1 as 1, and then it will be transformed to q2 and it is replaced by b and move towards the left. So which means the pointer will be moving towards the state q2, where 1 is replaced by b and the header will be moving towards the left, left in the sense at 0. Now it is at a q2 state. So now move will be delta of q2 of 0. So if we give q2, for q2 as input 0, then the output will be same state q2 and no change 0 and moving towards the left. So if we see here, the pointer is at a right now, and the move for now, actually we are in q2 state, right? So the move will be for q2 is, if we give q2 input a, so now actually the pointer is at a, right? So now, and we are at state q2. So now for the state q2, if we give input a, then it will be transformed to state q0 and replaced by a, and we will be moving towards the right. It means that we will go to the state q0, and where is a is replaced by a, and header will be moving towards the right. And the move will be, now we are in q0 state. So if we give q0 state as 0 input, then that will be transformed to state q1, and 0 is replaced by a, and header will be moving towards the right. So if we observe here, pointer is at b and 0 is replaced by a. Next, the move will be for delta of q1 comma b. So now we are in q1 state, right? So previously the pointer is at b. So if we give input as b, then it will be in the same state q1 and the no change in the symbol, and the pointer will be moving towards the right. Now the move will be, so if we observe here, when it is right transformation, so here the move will be delta of q1 comma b, where is delta of q1 comma b comma r, which means that it will not change any symbol, remain in the same state and move to right as well. So the move will be of delta of q1 comma 1. So now we are in q1 state and the header is pointing towards 1. So if we give 1 as input to the q1 state, then that will be transformed to q2, and the symbol will be replaced by b and the header will be moving towards the left. So 1 is replaced by b and the header was moved to the left. And now we are in q2 state, and if we give input, since the header is at b, then if we give input b to the q2 state, then we will be getting q2 comma b comma l, in the sense we will be in the same state, and b is replaced by b, no change, and header will be moving towards the left. Now immediately before B is A, that means all zeros are marked by A. So we will move right to ensure that number 1 is present. The move will be Q2 comma A. So that is Q0, from Q2 state will be moving to Q0, and A is replaced by A and will be moving to the right, which means it will go to the state Q0, will not change any symbol and move to the right as well. So the move delta of q0 comma b is q3 comma b comma, which means it will go to state q3 and there will not be any change in the symbol and move to the right as well. Now we are in the state q3 and header is pointing towards b, so we will be giving the input b to the q3 state. Then we will be getting q3 state in the same state, and b is replaced by b and header will be moving towards the right. Now we are at delta, so delta of q3 comma delta, where it will be transformed to q4, which means we will be going to state q4, and which is at halt, and halt state is always an accept state for any Turing machine. So this is how we solve the problem of a Turing machine. So basic model of a Turing machine. The Turing machine can be modeled with the help of following representation. So the input tape having a finite number of cells, where each cell containing one input symbol. Thus the input string can be placed on a tape. The empty tape is filled by blank characters. The finite control in the tape head, which is responsible for reading the correct input symbol. The tape head can move left or else right also. A finite set of states through which machine has to undergo. Finite set of symbols called external symbols, which are used in building the logic of Turing machine. So this is about the basic model of a Turing machine. So in this video, we have discussed regarding the basic introduction of a Turing machine and a problem regarding the Turing machine and a basic model of Turing machine. So this is Ajay signing off.